Backpropagation is a very cool idea of how AI is learning and give you cool results. So this is, I will show you first the image and then the animations. They're using chain rule on every single step. When you feed lots of images, for example, image recognition, sound recognition, when you unlock the smartphone with your face, it does image recognition very fast. How does it do it? So we feed lots of information into AI, machine learning, right? And then we give them some kind of observation, they call it observation, say your face. And then the computer has to go through lots of data to compare your face with other pictures, or to compare a dog to all pictures of dogs it's ever seen. So it goes forward first and gives some kind of approximate answer. I think that's a dog, or I think that's you. But then it goes back and calculates all the errors on the way back, because it will have several answers. It's a dog, it's a cat, it's maybe a mouse, but a dog has less error. So on all the ways, it collects all the errors and says a dog has a smaller error. Okay, so I guess it's a dog with probability 97%. So first of all, it's using partial derivatives on every single step. And then they sum them up. That's where the summation comes in. Partial derivatives. And it uses chain rule on every single step. All those weights are using chain rule. So my favorite ones are the ones that have cool animations. I show them in Calculus 1 class when we teach chain rule as well, to prove that this is pretty cool, have lots of applications. That's just one of the applications of chain rule, AI. So I feed the computer a picture of a dog, and I hope it will recognize it's a dog. But on every step, it has to compare 2 ears. The code cat and dogs, they have 2 ears. A tail. How would you explain to a blind person the difference between a dog and a cat? That's hard. So computer at least have thousands and thousands of images to compare to. So at least that can do that. And I mean millions of images. So it compares the size, the color, the tail, the face. And on every single step, it does chain rule, partial chain rule. And on every single step, it has an error. It has 2 ears, but because it's sideways like this, I'm not sure. So it's probability like 87% that it has 2 ears. Next step, I don't see a tail. I don't know. And at the very end, it goes back. That's why it's called backpropagation, and collects errors on every single step and gives you the answer with the smallest error. Pretty cool idea. So that is, I think, one of the most interesting applications. Chain rule on every single step. That's called artificial neural networks, and they use so many partial derivatives that they are using matrices to combine them in a nice visual representation. And then also they work with matrices, of course. So you see every single step gives you some partial derivatives. How cool is that? And my favorite one, for example, this one, if you know Gradescope, the grading program, you don't have to know it. But I was using it for several years. I would feed the computer with 100 exams from you, right, from students. And then the computer will learn from your handwriting how each number looks like. So from there, the computer will actually recognize your writing of number 3. I think this is the one I wanted to show. No. So AI is learning from all kind of images how to recognize stuff. So this one, for example, is kind of complicated. I will show you why. Look at that. What is that? You know, like, who knows? So even if I'm hesitating to know if it's a cat or a dog, if it's a sweater, then how would AI know? So AI will have insight layers, inputs, activation neurons, partial derivatives on every neuron step. Neural network is working and probably gives you a correct answer, dog, with some probability, which is pretty awesome. And then let me find the video I like. Cats and dogs. Where's this cool video? Image recognition. Probably I just should do that. Image recognition. This is only about image recognition, but actually it can be anything. AI nowadays is making its own art, making its own writing, and so on. So that one is even more complicated. That one actually uses vectors because it has directions. It's going back and forth. So it does use vector calculus a lot. This is the one I wanted to show you. It recognizes number 9. This is the bad handwriting. Is it 9? Is it G? I don't know. So we're feeding computer with thousands of handwritings, and with some kind of probability, it tells you, yeah, I think it's 9. Even though it does look like G and some numbers as well. This answers a little bit of your question of applications. Neural networks are pretty amazing, for sure. Can't find the guy with the guitar. Okay, this one is also 2. So my colleague, she's working on automatic cars. They're using lots of calculus 3 there. Okay, fine. Lots of integrals and lots of vector calculus. Lots of sums. Are you guys talking? Can you please concentrate? Thank you. So this image recognition works also with some percentages. Every time there's a chain rule involved in every single moving person. And it's never 100%. So a computer has to tell you, I think it's a bus with some kind of percentage or not. So that's pretty cool. So they're already using actively in some countries, which is kind of scary, but you know, it is what it is. No? Okay. Nobody answered. Okay, let's keep going with the example.